So last week we learned about scalar quantities, vector quantities. And the important thing for scalar is there is magnitude. Okay, the important thing about vector quantity is that there is magnitude and also direction, right? So I think this example 1.5 is a very good one to help you understand when we got a magnitude and direction one, or when we only got magnitude one. Okay, that will tell you when is it scalar, when is it a vector quantity. Okay, and then we also did some, this one later remind me before our class end, later remind me to give you guys the answer for this one. So if you haven't finished the question, never mind, you can write down the answer somewhere first, and then you can try yourself. Okay, if you have finished, you can straight away mark yourself also can. Then if you got any question, you can ask me. Okay, in the last 15 minutes, I will go through this one. Then got any question, you guys ask me. Okay, so in the second subtopic, we learned about some shapes of graphs. Okay, some shapes of graphs. We learned about what is directly proportional. Okay, directly proportional is probably one of the most important one. Okay, the most important one amongst all the shapes of the graphs. Directly proportional must start from 0 and go up like that. Okay, directly proportional. The gradient is a positive value. And then inversely proportional, also quite popular. You have a graph that looks like this one. Okay, the rest would be increasing linearly or decreases linearly. So everything in this table, I think, is all you need already. And I think it's quite complete here, right? And we'll go on to example 2.1 today already. Yeah? Okay, in this example, it's a bit mathsy. Okay, we are going to do things that are quite a lot of maths one. So let's see first. They say find the equations for the following graphs and the values of the unknowns stated. Okay, so this is going through some basics of straight line graphs. Okay, this is important because sometimes after you plot a certain graph already, or sometimes you have a graph and you want to find the equation. Maybe you want to find the equation to get other values, like what we are going to do in this example. It is going to be quite helpful. Okay, so to find equation, last week we briefly talked about it, or in Form 3, you also learned about it before. We're going to use the equation of straight line, which is y equals to mx plus c. Okay, don't worry, this one not difficult one. The meaning of m is the gradient. Okay, the meaning of c is the y-intercept. Okay, we're on page 7, by the way. So gradient is what? Gradient is the y value, okay, the y value over the x value. I know in maths you do y2 minus y1 over x2 minus x1, this formula. Okay, but usually I like to just look at the height, which is 8, okay, the y value over the length here, the x value. So the gradient, right, is going to just be 8 over 4. Okay, 8 over 4. And remember, last week I taught you that all your gradients that are positive will look like this one. All your gradients that are negative will look like this one. Positive gradient, negative gradient. It looks like an A shape. Okay, it looks like a letter A at it. Positive, negative. Okay, so this one is positive gradient. That's why in front here it's positive, or you don't write also can. So our gradient is equals to a 2. Can I just take the y over the x values? Okay, 8 over 4. And the y-intercept is equals to 0. Okay, the y-intercept is where your graph cuts the y-axis. Intercept means the place that it touches, the place where it cuts. Okay, so the c here is 0. The reason why I want to write the M and the C is because the question asked me to find the equation of the graph. Every straight line graph, any straight line graph at all, as long as it's a straight line, you can join it with a ruler one. You can always use y equals to mx plus c. Okay, so now we can put into our equation already. Y is equals to mx plus c. You see your graph, your y is here, your x is here, your m is 2, your c is 0. So m is 2, x is still x, the c is a 0. Okay, the 0 we can don't write, so we write that. Okay, so we answered the question already. This is the equation of the curve. Okay, this is the equation of the curve. The thing that might be confusing is probably the gradient only, I feel. Okay, because the y-intercept just take where the graph cuts the y-axis only. So remember, take the y value divided by the x value. That is how you get the gradient, y over x. Okay, y equals to 2x. Then the question also asks you to find the value of x when y is 20. Okay, so let's do that. When y is equal to 20, we are going to put it into here. When y is equals to 20, okay, I am putting this as 20. We want to know what is the x value. So to get the x value, we will just divide the 2 to the other side. Okay, x will be equals to 10. Okay, so after you get the equation, it's very convenient because you can sub in any x value, you can sub in any y value, okay, to get the answer. Okay, sorry, a bit no space. I'm squeezing everything in here. Let me move a bit now. Okay, so at any straight line, you can find the gradient. You can find the c, and then you put into y equals mx plus c. Then you can get the equation already. Equation, very useful one. You can sub in any x value, any y value, you can get the other one. Okay, you put in x, you will get y. You put in y, you will get x. Before I continue to part B, is there anything that you don't understand here? Is there anything that you guys want me to explain? If okay, can you guys just say okay in the chat? Or when you're done, you just say okay, then I know I can proceed. If got anything, you can unmute your mic and let me know. I can explain. Okay. Yeah. Thanks, Ayman. Thanks, Chloe. Can or not? Okay, got any problem, must let me know. Okay, in part B, we are going to do the same thing. Question also asked me to go and find what? Find the equation of the straight line first. Okay, equation of the straight line. Any straight line can always use y equals to mx plus c. Okay, we will start with the gradient first. Can you guys tell me, right? You see, to find the gradient, I will need to know what is this height and what is this. Okay, so can you guys go and put down the coordinates on the axis? Okay, 4 and 8. And then here's 4. And here's 0. Okay. Because to find out the gradient, I need to know what is the distance for the y, what is the distance for the x, and I need to divide them. Okay. Chloe, can you help me? Chloe, can you help me? The distance, this value is how long is that distance? The distance in the y value from 4 until 8.
4?
Yeah, it is 4, correct. Thank you. This is 4. Then down here also 4, right? From 0 until 4. Okay, 0 until 4. Thanks, Chloe. So the gradient is equals to 4 divided by 4. Okay, you can always draw a triangle like that one, connecting the any 2 points in your graph. Okay, any 2 points in your graph. So the gradient is 4 over 4. And then I'll ask myself one very important question. Is this a positive gradient or is it a negative gradient? Because negative, I cannot forget to write the negative. Okay, so I'll think again. Positive look like this, negative look like this. This is a positive, so I don't have to worry. Gradient is just 1. The y-intercept. Okay, the y-intercept is where the graph cuts the y-axis. Is a follow. Okay, where the graph cuts the y-axis, so it's the 4. And then after that, I can put everything into the equation already. Y equals to mx plus c. Okay, I know what is the m. The m is a 1. The c is a 4. But right, I want you to know that not all the time it is going to be a y and an x like that one. Okay, it's not all the time it's y and x. You have to be careful and look at the graph. Okay, because in physics we are not dealing with maths, right? It's not really maths. Okay, maths you learn maths lah. Physics we are dealing with could be anything. Could be velocity. It could be speed. Okay, can be many things. So we are dealing with all these physical quantities. Usually they have their special symbol. It's not always all the time x and y. So you have to know that this v up here is the y, right? So instead of writing y, I'll write a v. Okay, instead of writing y, I'll write a v. Okay, and then instead of writing x, I'll write a u. Okay, I'll write a u. This one can understand or not? Okay, so it's based on the graph. Huh? Here is always what we put as the y. Here is always what we put as the x. If you ever see people write v, then you don't write y anymore, you write v. If you see people write u here, then you don't write x, you write it as a u. Okay, so this is the equation, but I can make it look a bit nicer. Usually we don't write the 1, we just write u, because 1u is the same as u. Okay, now they ask you, find the value of v when u is equals to -10. You see this equation? If I put inside a u value, of course I can find a v value. Or if the question gives me a v value, I can definitely find out a u value also. Okay, so I'm going to put substitute u as, okay, like you can write properly, sub in u equals to -10. So v will be equals to -10 plus 4. Okay, then you can use your calculator. -10 plus 4 is -6. This. Okay, so now we already learned how to form equation of straight line, which is by first finding gradient. Next, look out for where your y-intercept is. We also learned that if I got the equation, I can sub in any values inside to find out the other one. Okay, like if you are finding u or finding v, we can use the equation. Okay. In the next part, right, I want you guys to try doing the gradient. Okay, when you're done with part B, try to find out the gradient of this part C graph. Okay, you ask yourself, what is this distance divided by this distance? Okay, I want you guys to do the gradient. And then you also think, is this a positive gradient or is this a negative gradient? If negative, don't forget to add a negative yourself. Okay, and also what is the C value? Okay, find out your M and your C first. Okay, I give you 1 minute to do that. Find out your gradient and also your C, or 30 seconds. Okay, find out your gradient and also your C. And if you can, try to write out the equation yourself. Okay, try to write out the equation yourself. Iman, can you tell me, you try and see now, wrong, never mind, try your best. What is the gradient of part C? Okay, what is the gradient? And then Connie, can you just type out what is the C value? What is the Y-intercept? If not sure, never mind. You just write not sure in the chat. Then I'll know whether to explain. Yeah, very good. Thanks, Connie. Ayman, do you know what is the gradient or not? Yeah, the gradient is 3. Very good. Very good. So, oh, okay, there's one thing that you forgot. Okay, there's one thing that you forgot, Ayman, which is the negative sign. Positive gradient like this, negative gradient like this, right? Remember the letter A? Positive, negative, huh? Okay, so negative 9/3. Here's 9 and here's 3. Okay, very good. So we will get -3. Okay, but the value is correct, huh? So very good. And then Connie told me that the y-intercept, the C is 9. So if I put into y equals mx plus c, okay, I will write like this. What is the y? This time they are not using y again. They're using something else, which is t. I follow with t. M is what? M is -3. X is what? X is L. Okay, X is L. And then C is +9. Okay, C is +9. So this is the equation of the straight line. Da-da-da-dang. Okay, be very careful with the gradient now. Be very careful with the gradient. If this is the first few times you're doing, it's normal to forget the plus minus sign. But it makes a huge difference. When is it positive? When is it negative? Because a graph that goes like this, right? It means that it's going down, the value is decreasing. That's why the gradient is negative. A graph that goes like this means it's going up. Okay, this is positive. The values are going up. So it makes a huge difference. Now we are going to find out what is the value of u when t is -21. Oh, sorry, there's a typo. Can you guys change the u to an L? You see in this question, this one is u, right? Can you change it to L? Sorry, typo. Okay, so t is -21. We're looking for L. Let's do this slowly. You can, I don't know how you guys prefer to do it, but you can, if you want, you can move this to here, becomes +3L. The 9 I didn't move, so 9 stays here. -21 move there, become +21. Okay, so I'm dealing with plus become minus, minus become plus. Uh, 3L equals to 30. 30 divided by 3 is a 10. Okay, 30 divided by 3 is a 10. Okay, and then this one, also another negative gradient. Okay, negative. ask yourself the same question to find out the gradient. What is the y distance and what is the x distance? Okay, sometimes it might be helpful to put down the coordinates. You guys try, find the gradient and see yourself. Then find out your C value. C value is 6. You see the graph now, they put t squared. You just follow only. Okay, they never write y, they write t squared. Never mind, you just follow. Y equals to m x plus c. This is your equation. Okay, so now we learned that I just want you guys to get used to finding gradient, finding c. And after that, from there, put in the y value and the x value. Sometimes the x and y, they might not be x and y, they might be other things, other physical quantities. So the capital letter T could be representing temperature maybe. Okay, M could be representing mass. Maybe they can talk about time, so they might put time in the graph also, right? It doesn't matter one. Okay, so get used to the idea because this one is not maths, right? We're dealing with physics, so a lot of physical quantities. Then question also say, find the value of P when M is 2. When M is equals to 2, let's put 2 inside the M. Can any one of you type this in your calculator, the whole thing? Just type the whole thing in the calculator and get the answer for me for this one. Okay, the value of T squared first. Okay, thank you, Chloe. Yeah, you get a 3, right? And then the value of P, right, will become move square to the other side. When I do times, I move to the other side, it becomes divide. When I do plus, I move to the other side, it becomes minus. When I have square move to the other side, it becomes square root. Okay, square root of 3. Right, so the answer is square root of 3. Okay, when you are ready to move on to the next question, you let me know. When you're done, you just say that you are done. When you're done, you just let me know, then I'll move on. Yeah, I know in that maths, usually we write plus, minus. So this one, you can write plus, you can write minus. Because our graph, right, you see our graph. Let me show you. Let me rub off all this a bit. When my m value is 2, you see this is a positive value, right? Okay, this one is a positive value. So for this case, we can just take the positive value, but there's nothing wrong if you want to put plus minus. Go ahead. Okay, plus minus. In physics, most of the physical quantities we deal with are usually positive. Okay, so we will look at the situation usually. Does it make sense to have a negative answer or not? If it doesn't make sense, then usually we just take the positive value. Most of the time in physics, it's just positive, not so particular. But at maths, yeah, you must put plus minus. Okay, that's a good question. So you guys write plus minus square root 3? Can. You guys write just square root 3? Can. Okay, for now it's okay. Right, because now this one is not really a real life situation where we are dealing with some quantities, so we can't really tell whether is it positive or negative just yet. But if later on we encounter this kind of situation again, then we will see whether or not it makes sense to have positive or negative value, which one makes more sense. But don't worry, in physics you rarely have this kind of situation. Most of the time is positive. Okay. Okay, thanks, Aiman. Chloe also done, right? Okay. Connie also done. Okay. Thank you. All right. In example 2.2, find the gradient and the y-intercept for each of the straight line graph. Okay, let's look at part A first. All these, they are straight lines. All these, they are straight lines. We will always look at y equals to mx plus c. So I just want you to draw a tiny little graph here. Okay, and just put down these two axes. When they say y against x, I want you to know that it means y is on top, x is at the side here. Okay? Y against x. The one that they say first, right? Something against something. The first one will go to the top first. The second one will go to the bottom. Okay, so if they say y against x, and you go and draw like this one is wrong. Huh? Okay, y must go to the top first. It is always like that. For maths, for maths, anything, always like that. Okay, physics, all like that. All right, so I just want you to draw a small graph like this, and then you will know what it means like that. After that, right, based on y equals mx plus c, I know that this equation has a gradient. Okay, they want you to just take the gradient and the y-intercept. You can just write m and c. The gradient is 7, and the y-intercept is a 0. Okay, the gradient is 7, and the y-intercept is a 0. Okay, and now you just look out for these two values. As long as you arrange y and x like this, then can it y and x. Okay, then we try part B. Now this time, they say V against U. So this graph is V against U. Okay, and our equation I got is V equals to 5U minus 2. V is here. U is here. Okay, it is already arranged in the form of y equals mx plus c. So if I ask you what is the gradient would be -5. The y-intercept would be -2. Okay, -5, -2. Okay, and now the gradient comes from here. The y-intercept is behind one. Okay. So all the blue color I will highlight as the gradient, so that it's easier to see. All the green color one would be the y-intercept. Part C, this time the graph I'm drawing is R against T. R against T, we're going to put down in the graph. R is here, T is here. However, the equation, right, they give me R minus 4T equals to 2. Okay, usually y equals mx plus c, the y must be a lone one. Okay, the r should be a lone one for this question. So if it's not alone, what you need to do is just move the minus 40, minus move over become plus, plus 40. The 2 is plus 2 lah, this. Now you can clearly see already. The R and the R is here, the T and the T is here. Same like all the other questions, right? The gradient is what? The gradient is this 4, positive 4. So if you never arrange and then you go and say that the gradient is negative 4, then salah already. Okay, we wouldn't know what is the gradient unless you arrange in y equals mx plus c. So make sure that you always arrange this first. Okay, how to get the y? The y is the r, whatever you see on top. How you get the x? The x is whatever you see at the side here. For this case is capital letter T. And then the y-intercept is positive 2. Okay, so let's write down gradient is 4, y-intercept is 2. Okay, part D, I want you guys to help me a bit. So I have the graph. We are drawing same thing, R against T. R against T. Okay, I got not enough space, I write at the side here. So I got 2R plus 6T equals to 5. Okay, can you guys go and rearrange this? Try to arrange first. Okay, you want y equals to mx plus c. So your y is what? Your y is r. And then you want to arrange so that the x becomes a t. Then you have some gradient value here, and then you have some c value here. Okay, try to make this r become alone. Okay, so this one depends on your maths. Try and see to do. Slowly, slowly move. First step, we must move the 6t first. Plus move over become minus. I'm getting closer and closer already. Okay, and then you can do something. I don't know how you guys usually do it, but what I like to do is I can divide everyone by 2. Okay, or you can divide the 2 over. You divide everyone by 2, right? What happens is you have, you see, divide by 2, divide by 2, divide by 2, left r, left negative 3t, and then plus 5 over 2. Okay, straight away you get your equation already. Okay, straight away you get your equation already. Or I know some people, they like to write like this. R equals to negative 6t plus 5 over 2. Also can, but then this one is a bit hard to see. It's a bit hard to see what is the gradient value. The gradient is negative 3, but from here we cannot tell. And the y-intercept is 5 over 2. So if you have something like this, you still have to further split up. Okay, further split up, and then only you can say this. All right, so try and see this method. Okay, try and see this method. All of it divide by 2. So R is equals to negative 3t plus 5 over 2. Okay, the gradient is equals to negative 3. The y-intercept is 5 over 2. Okay, I'm sorry if there's not enough space. I'll try to add more space next time. Okay, so there's R and there's T here. The gradient value is negative 3. The y-intercept is 5 over 2. Okay, if I divide by 2 for everyone, I'm being fair. I never leave anybody out. So if you can actually do divide by 2, 2, 2 like that. The reason I want to divide by 2 is so that I can cancel out this 2. Now it becomes only R, which is what we want. Okay, so I know if your maths is a bit wobbly here, you might find this one a bit hard to understand, but I just want to know if everyone is okay with this. Understand what is going on. This is more maths already than physics. Okay, Ayman? Okay, thanks. Thanks, Chloe. Don't really understand, must let me know. Okay, thanks, Connie. Right, and we also try the next one. Okay, now we are dealing with a graph that is R against, this thing is called theta. Okay, this thing like that is called theta. It's one of your Greek letters. Okay, it's one of your Greek letters. In MS, you have learned alpha, you have learned beta. Okay, theta is just one of the Greek letters. So we got R and theta. Theta usually is representing an angle. Okay, but what is more important is we want to rearrange this. So I copy the equation first. Okay. I want to arrange so that my y will become a r and my x will become a theta. Because from the graph, I know it's like that. Okay. But right now, you see this theta is hidden inside here, inside the bracket. So I think I need to multiply the alpha to open it up. Okay. This is alpha. When I say alpha, I hope you know this. This is alpha. Like that is beta. Beta is like a capital letter B with a small little tail at the bottom. Okay. All these are just unknowns, are just Greek letters. Okay, and then you see what I'm going to do here is I'm going to write alpha, beta, and the theta first. That is. Now you can see clearly that R is here and the theta is here. Just know that the alpha, the beta, and the alpha there are all just numbers only. It's just that instead of putting numbers, sometimes they can put some unknowns also. Okay, unknowns are actually numbers. It's just that we don't know what's the number. Maybe this alpha is a 2. Maybe this beta is a 3. So maybe this one is just 2 times 3. And then maybe this one is a 2, right? So it can be any value, but we just don't know what the value is for now. Okay, so don't worry too much about that. The gradient is still going to be whatever multiplied to your theta to your x. Your x is theta. Your y-intercept is still whatever behind that. Okay, so m is equals to alpha beta, and the c is equals to alpha. Okay, again, so this question just a bit different, just trying to practice how we arrange things into y equals mx plus c. Sometimes you might not get numbers, same one. Okay. Okay, and then last one, f. P against n, P against n. So I got P minus Sn equals to W. Here also got some space. If you're running out of space, you can write it in here also. I should have put more space here. Okay, so I need to think how I can make P alone, and then the n is the x, okay, mx plus c. And this one is quite simple because I can just move Sn to the other side plus W. I got the Y already. I got the P already. The x also I have already. Okay, the gradient also I have. The y-intercept also I have. Okay, so the gradient is S, the y-intercept is W. Okay. So this is the practice of y equals mx plus c basically. Just you must tell yourself this is the y, whatever you put here. This is the x, whatever you put here. Okay, the m is the gradient, the c is the y-intercept. So x and y, sometimes they can change to put other things also. It's the same one. Okay. So all these things are just so that you understand a graph better. Whenever you see a straight line graph, at least you know, oh, I know this is negative gradient, I know this is positive gradient, because trust me, a lot of students actually cannot really tell positive and negative gradient. They cannot really tell y-intercept. They cannot really know, they don't really know what is the gradient and things like that. So if you know all these things, some objective questions you will be able to do quite fast on. And then maybe for your experiment, for your paper 3, remember paper 3, I said you are going to do an experiment, right? 15 marks. You probably also need to draw a graph yourself. Okay, and from that graph, it could be a straight line graph. If you know it's a straight line graph, we know in physics we are dealing with different physical quantities. So we will probably know what is the gradient, what is the y-intercept, and things like that, and whether it's a positive, negative gradient, right? So all these things will help you to understand better of the graph, right? Okay. When you are ready, we will move on. I'll continue with the next part. Okay, I'll continue with the next part. Right, so analyzing graph, whenever we are analyzing graphs, we are trying to build a relationship between two graphs. That is the first thing we want to do. Okay, if I have a graph, I give you a graph. The first thing that I can always tell based on my graph is the relationship between the graphs. Okay, the relationship between the graphs. So in this question, what we want to do here is to state the relationship between the two variables of the following graph. Okay, you can, if you need help, you can refer to this table here also. Okay, you can refer to this table here. Right, we know that if the graph starts with 0 and it's a straight line like this, okay, we call it y is directly proportional to x. Okay, y is directly proportional to x. Very important. Exam like to ask this. Okay, maybe they never put y and x in exam. They ask you v and t. Okay, you might see this in your first exam. Then you say v is directly proportional to t. Okay, same one, same. Okay, so if you see like that, remember this one must know directly proportional. Very important. Okay, the second one. This one would be y is decreasing linearly with x. Sorry, with x squared. Okay, y is decreasing. That means getting smaller and smaller and smaller. You see the value of y from maybe this value is 10 and then slowly become 8 and then slowly become 6. It is decreasing. Okay, decreasing. Linear means what? Linear means decrease in a straight line. Okay, remember last week we mentioned linear means straight line. Okay, decrease in a straight line with not x or with x squared. Okay, with x squared. Okay, what if in exam you see a question like this? Okay, then they ask you state the relationship between y and also square root of y and square root of x. So people say this one you can refer to the table above. It's a very special shape, and only this kind of shape is called inversely proportional. Okay, inversely proportional. Number one most popular is directly proportional. Okay, number two most famous one is inversely proportional. You must remember that the curve is curved down like that, and then it won't touch the y-axis, and it won't touch the x-axis, meaning it won't be like this and then like this. Okay, it will curve this way only, right? So for this graph, we will say that y is, okay, y is inversely, okay, inversely proportional. Know how to spell these words? To square root x. Okay, in your entire syllabus of physics, you're going to do a lot of this. You're going to do directly proportional a lot. You're going to do inversely proportional a lot. Okay, decreasing linearly, increasing linearly, that one not as popular. Okay, but not as popular, but they ask once in a while. Most important one is directly proportional and inversely proportional. Okay, direct means direct, oh, direct go up, go up, go up. Inverse means the opposite. Go down, go down, go down, go down. Okay, one is go up, one is go down. Next one. This one also directly proportional. So we can say y is directly proportional to 1 over x. Okay, y is directly proportional to 1 over x. Okay, so when I see a graph, the first thing I can talk about is the relationship. Okay, if exam asks you, state the relationship between x and y, or like I said just now, I can change the question and then I put between v and t maybe. Okay, then they give you a shape like this. Then you can say, oh, v is directly proportional to t. Okay, 1 mark for you, right? Like that. Other than that, whenever you are analyzing graphs, right, we can also get the gradient of the graph. Gradient of the graph. So gradient is the y distance over the x distance. Okay, y distance over the x distance. You want to use this formula that you learn in Form 3, maths also can. Okay, but usually I just take what is that height over what is that length there, the y distance over the x distance. Then I know what is the gradient already. Okay, then I know what is the gradient already. Just need to put in positive or negative yourself. So in this question, right, it says that the graph shows how the velocity of an object varies with time. Remember I told you that velocity is one of the terms that you will learn more in detail in the next chapter. So for now, you just think of velocity like your speed like that. Okay, it's like your speed like that. Okay, you see if the graph go up like this, it means that as the time increases, we are talking about v varies with t. That means velocity against time. Okay, velocity against time. As your time increases, you see at the first part from 0 to 10 seconds, the velocity also slowly increases. The speed also slowly increase. Okay, so maybe at 5 seconds at time, the speed is maybe like 20, and then slowly it increases. That is how we read the graph. Okay, that's how we read the graph. And then after that, from 10 to 20 seconds, the speed remains the same. That means imagine you're driving and then you remain at 40 meters per second. Okay, you never increase the speed, you never reduce the speed. You remain at the same speed. Okay, you remain for 10 seconds. And then after that, the speed you slowly reduce already. Okay, the speed is slowly reduced. Okay, so this is how we read the graph roughly. Yeah? So in part A, they ask us, what is the gradient of the graph from what is the gradient of the graph from 0 to, oh my bad, I made an error here. Can you guys change this 5 to 10? So sorry, can you change this 5 to 10? And then this 10, this one is 10 to 20. This one is 20 to 30. Sorry, can you change the question from, this one also the same, 0 to 10, 10 to 20, 20 to 30. Okay, so sorry, can you change all this question to like this? Okay, I think Connie got disconnected for a while. You change the values, Sorry, I made a mistake with the question. Okay, 0 to 10, all the red color one you change. Okay, sorry, And then we are going to find out the gradient from 0 to 10 seconds. So let's focus on 0 to 10 seconds only. Okay. There's space down here, so you can write down here. Starting with A1. From 0 to 10 seconds, the gradient is a positive value. And then I know this one is negative value. So the gradient is equals to, the y distance here is 40. The x distance here is 10. So it's 40 over 10. Okay, that's for number 1, 0 to 10 seconds. Number 2, for 10 to 20 seconds. Number 2, for 10 to 20 seconds. Is there any y distance or not? Is there any distance in the y? No one, there's no distance there. So it is 0 over, here is what? Here's 10. Okay, from 10 to 20 seconds. So 0 over 10 is just 0 lah. Okay, 0 over 10 is just 0. Sorry, I forgot a very important thing. I forgot the units. Physics cannot forget unit, right? Okay, so the 40 that I put just now is meter per second. Okay, the y-axis is in meter per second. Over, down here is in seconds. Okay, the 10 down here is seconds. So meter per second divided by seconds is going to be meter per second per second. Okay, meter per second squared. Divide means minus another one. Okay, this one also the same. 0 meter per second divided by 10 seconds. We have 0 meter per second squared. Okay, and then the last one, from 20 to 30 seconds. The y distance is 40, the x distance is 10. Okay, this is 10 seconds, this is 40 meters per second. And the gradient is negative. Okay, the gradient is negative. So negative, put down the negative first. Y distance is 40 meters per second. X distance is 10 seconds. Okay. Yeah, you know what? Rather than enlarging it, I'm gonna put this here first. Later, I'm gonna paste down there the space so that I can refer to the graph and also do the working one shot. Okay, so they can see everything in one screen. Okay, for you, you write down that the space there. So this is going to be -4 meter per second squared. Okay, this one we are answering for part A, finding the gradient. Okay, finding the gradient. So now we know that, oh, if it's a horizontal line, a flat line, the gradient actually is 0. And then if it's a line that slants, go down like that, it's a negative gradient. Okay, so we have gradient equals to 4, gradient equals to 0, gradient equals to -4. Don't forget about all the units. Huh? Okay, and then before we do part B, let me explain a bit of things first. Gradient, okay, huh? Other than every time I see a graph, I can form a relationship, number 1. Number 2, now I know I can find the gradient. Number 3, I can also find out the area under the graph. Okay, I can also find out the area under the graph. So there are some common areas that we have learned last time in your lower, maybe in primary school also, you have learned some formulas already, like square. Okay, square is base times height. Triangle is half times base times height. And maybe trapezium. This one a lot of people forget, right? But area of trapezium is 1/2. The A plus B is the parallel sides. Okay, the A plus B is the parallel sides, and the height is from here to here. Okay, trapezium. Right? So area under the graph meaning like this, huh? This is like this one. This is area. But if you forget trapezium in exam, right, you can also split it up into a triangle plus rectangle like in this diagram here. Okay, so let's go and find out what is the area under the graph. Okay, so now I'm teaching you when I see a graph, what can I do for this graph? I can state the relationship, find the gradient, find the area. So for part B, we're going to find out the area. I'm going to put this down here first. And now I'm going to do part B already. Okay, what is the area under the graph? Why we say under the graph? The graph from 0 to 10 seconds for part B1 is like this. This is the graph. They want underneath the graph, below the graph. That means here. Okay, this is the meaning of it. We know that this is a triangle. When it's a triangle, the formula for area of triangle is 1/2 times the base times the heights. Okay, 1/2 times the base times the height. That is the area under the graph from 0 to 10 seconds. So part B1, 1/2 times. The base here is what? 10 seconds of 10 seconds. The height is 40 meter per second. Okay, so what is the answer? You can use your calculator, type 1/2 times 10 times 40. Okay, 1/2 times 10 times 40. You will get 200. But what is the unit? Okay, what is the unit? If you have second multiplied by meter per second. Meter per second is the same as meter over second like this, right? So you cancel these two, S and S, or time with time, you will get meter. Okay, you get meter, which makes sense lah, because last time in PT3 you learn speed equals to distance over time. Your velocity is like speed like that. Okay, or you probably have learned this triangle before, distance, speed, and time. Okay, so if you want to look for, now you see we are looking for the distance of in meters. Okay, distance is speed multiplied by time. Speed multiplied by time. Okay, you throw the time go up, distance is speed multiplied by time. So the area we will get in meter for this case. Part 2, the area under the graph for 10 to 20 seconds. For 10 to 20 seconds, the graph is here, this green color place. Underneath it, we want all the graph that is underneath it. Okay, this looks like a rectangle to me. Okay, this looks like a rectangle to me. So the distance here is 10 seconds. The height here is 40 meter per second. Rectangle, very simple. Just base times height. Okay. I'll get 400 meters. Okay. Second multiplied by meter over second is meter. And then last one. Last one, can you guys try and get me the answer now? We want the area of the graph from 20 to 30 seconds. So area, I don't have to worry about negative, positive, because area don't have negative or positive one. Okay, area is always positive. You want the area under this part. Anyone of you got the answer already, you can just type in the chat, or you can just tell me, mute your mic and tell me. For part 3, huh? Still 200. Okay, a triangle is 1 over 2 times the base length times the height. Okay, so it is still going to be 200 meters. Okay, so we have done already. I'm going to paste this one back to the space here. Okay. Okay, I hope you know how I get the area that is below the graph until the axis there. And so from a graph, we can get the relationship directly proportional, inversely proportional, and things like that. We can get the gradient. We can get the area below the graph. Okay, done. And then they say, part C, based on the units of the gradient and the area under the graph, state the physical quantity that they represent. Okay, based on the units of the gradient. The units of the gradient here is meter per second squared. Meter per second squared. In Form 2 maths, you have learned one chapter called speed and acceleration. You should have known that the acceleration, right, is equals to the change in speed or the change in velocity divided by time. Okay, that is why you see your formula all is in speed or in velocity one, and then divide by time. Okay, this one we will learn more in chapter 2 also, so don't worry about the definition or the formula just yet. But I want you to see the unit only, and then you can probably know that the gradient represents the acceleration. Okay, the gradient actually represents the acceleration. So if I have a graph that is velocity against time, okay, you will know that, oh, the gradient actually got some meaning one. That's why we go and find the gradient. It actually represents the acceleration. And then what about the area? Looking at the units of the area. Okay, looking at the units, we'll probably say that, oh, this one is distance. Okay, this one is distance. But we know that because this one is not speed, they use velocity. Okay, they use velocity. So velocity, the formula all this you will learn in chapter 2. But I'll just write down here first. The velocity is displacement divided by the time. Okay, so whenever you're dealing with velocity, and then you go and multiply the time. Okay, you see velocity and multiply by the time, you will get the displacement, not distance. Okay, it is not distance based because of the formula, right? If you use velocity, then it must be connected to displacement one, because velocity is a vector quantity. Speed is a scalar quantity. They are different a bit. Okay, so the area under the graph represents the displacement. Okay, just look at the unit. You will know either is distance or displacement already. That is the physical quantity that they represent. Yeah, so in this example 2.4, I've covered two things, gradient and also area. Okay, gradient and also area. Okay. Oh, why for area the unit is in meter? Okay. Yeah, area is usually meter squared. You are correct. But we are not doing area for a shape, right? Okay, I'm not doing the area for a shape. For example, if I have a shape and then I have 2 meter, and then here, or maybe this one is 4 meter, and then here 2 meter, then it is 2 meter times 4 meter equals to 8 meter squared. Okay, 8 meters squared. But if you are dealing with the area for a graph has different units on. Okay, maybe sometimes here can even be temperature, and then here would be maybe volume. Then the units will also be different. So for example, if you maybe have, I give you a very easy one, a straight line. Okay, so what is the area here like that? I will take this one, multiply by this one. Okay, then you will get what? Volume, maybe we use liter. Temperature, maybe we use degrees Celsius. Then the answer will be different already. Maybe you have 10 liter here. Maybe you have 20 degrees Celsius here. Okay, the area under the graph for this straight line is just 10 times 20. Unit again is going to be a different thing. Okay, so yeah, you are asking a very good question. Don't get confused that don't get confused with the area that you do in maths usually. Maths is the one is for normal shapes. Right now, all our axes got meaning already, right? Right now it's just not x and y anymore. got meaning already. So we have to look based on the units there and then see ourselves how to do S multiply with meter per second, second times meter per second. Okay, that's how I get the unit of M. Like in this example, I give you, it might be liter and degree Celsius that stick together. Can you understand? Okay. Can everyone else got other questions? Not must. If you don't understand anything, let me know. So the units, you just refer to the graph only. Don't overthink. Just refer to the graph. You do Y value, that one is meter per second. You do X value, that one is in second for this question. Okay, we continue. Right, other than relationship, gradient, area under the graph, there is also something called interpolation and extrapolation. Interpolation is something that you have done before. Okay, interpolation is something that you have done before. Let's say they give you a graph like this in this diagram. See, they give you a graph and they ask you to find some values. Okay, let's say I want to know what is the value of y when x is equals to 1.5. When x is equals to 1.5, I go and dot to the graph and dot to the y value here. You see, I'll get probably this value is like a 38 or 39 maybe. Okay, we cannot really tell for sure because this one is not drawn nicely on a graph paper, but it's roughly that. Okay, or maybe they give you a y value. Okay, let's say this y value they say equals to 25. Ask you to go and find out the x value. Maybe you draw this graph already, you can go and find out find out from the graph here. Okay, maybe the x value you will get is 2.4. So interpolation is you dot to the graph and then you dot to the other axis like that. Okay, that is what interpolation means. Extrapolation means you extend the graph. Okay, you extend the graph. So maybe the graph you draw is only this short. Okay, maybe the graph you draw is only that short. But the values that you want, right, is not in this short little graph here. Okay, the values that you want is not here. So let's say if I want to do like find out the value of 3, okay lah, that still can because my graph, this one is what we call as interpolation. But if it's not outside, if it's not within here, right, then what you need to do is you need to go and extend this graph, make it longer a bit. Okay, extend this graph, make it longer a bit. So extrapolation means extend the graph. Okay, after you extend the graph already, you can read more values already. Now you can say if y is equals to 3, then maybe I can read the x value equals to 1. Or maybe if x equals to 3 maybe this is negative 3.2, y value is equals to 1, for example. Okay, so inter means inside, within. Okay, inter means inside, within. Extra means outside. You extend the graph outside of it, outside of the graph. Okay, can you understand? Interpolation means part of the graph. You get the values from part of the graph. Extrapolation means you extend the graph and the values are from outside of the graph. Okay, inter means within, extra means outside of it. Okay, so we look at example 2.5. Okay, example 2.5. The graph shows the relationship between the volume and temperature of a particular gas. The gas volume is measured when the temperature is changed from 50 degree to 150 degree. Okay, so they draw out this graph already for you. Okay, they draw out this graph for you already. So part A, they ask you, what is the volume when the temperature is 25 degrees Celsius? Okay, we do one by one. When the Temperature. So temperature is here. Temperature is here. Volume is up here. When it is 25, 50 is here already. 25 is right in the middle. Okay, so you go and draw a line. Okay, you can draw a dotted line or what, but you can go and draw a line. I hope you can see the lines. It's a bit blurry, but basically you are able to read the graph like that. Okay, so every 5 box is a 10, right? Every 5 box is 10 because here is already 50 in the middle. So if you have, let's say, here is 50, 1, 2, 3, 4, 5. Here is 40. And then the place that we want is you dot, dot, dot until here. Okay, you dot, dot, dot until here. So this is 42, 44, 46, 48, 50. Each small little box is 2 by 2 by 2. Okay, so the value when the temperature is 20, when the temperature is 25 degrees Celsius, the volume is equals to, my one there is 46 cm cube. Okay, 46 cm cube. Now we're going to do when the temperature is 115 degrees Celsius, what is the volume? Okay, so this is what we call as interpolation. I'm reading from inside the graph. Okay, so I go to my graph, 115. 100 is here, 125 is here, 115, 105, 110, 115, 120, 125. Each small little box is 5 by 5 by 5. Okay. I will get a nice value. This one is right at 60. Usually I like to draw and just take my eraser and rub a few so that I know it's dotted. The reason why we use dotted line, right, is to show that all these lines that I go and draw, all this red color line that I draw extra, right, they're not really part of the graph. They're just helping me to get the values. Okay, so I want you to use your ruler and go and draw. Make sure you draw out how you get the values. Okay, we're doing 115. If you are not sure one small box is how big, right? You see here got 10 box, 10 small box. 10 box is 50. One box is what? 50 divided by 10. So one box is 5. That's how I know the next box is 105, 110, 115. Okay, so when temperature is 115 degrees Celsius, volume is 60 cm cube. Okay, 60 cm cube. The last one, when the temperature is negative 200 degrees Celsius, what is the volume? Okay, so for this one, we need to go and extend our graph because negative 200 is right here and up here don't have any graph, right? This is what we call as extrapolation. We need to go and extend the graph, then only I can read the values. Okay. So put your ruler and your pencil, you go and draw carefully. I think this is good enough. Something like this. Okay, something like this. Negative 200. So negative 200, you go up like this. It will touch on this line. Okay. Quite nice, this value. This value is 10. cm cube. Okay, 10 cm cube. And then part B. What is the temperature when the volume is 54 cm cube? Okay, you guys can go and read your values. Try to do it yourself. Now they give you the volume. Okay, now they give you the volume and ask you to find out what is the temperature. What is the temperature? Okay, 54 degrees. Fifty-four is somewhere here. Okay, if you have 54, here would be 75. Don't forget the units, 75 degrees Celsius. When it's 30 cm cube. This is 30 cm cube. You will get negative 75 between negative 50 and negative 100. Negative 75. That one is considered extrapolation already because it's not from the original graph. And then final one, when the volume is 0. When the volume is 0, see lah, you can write negative 25, negative 254, negative 256 also can. Okay, or negative 255 also can. Oh, sorry, what am I saying? Sorry. My bad. One small little box there is 5 units, right? One small box is 5 units. 125. Two five five 260, 3 boxes. 265. Okay, I think it's about negative 265. Mine is about negative 265. If you get negative 260 also can. If you get negative 270 also can. Okay, around there. So just a very curious question, right? If I have this graph and I want to find out the area underneath here, okay, the units will be what? The units, right, would be, this one is in cm cube mark. And then this one is in degrees Celsius. Let's say I have a rectangle. It would be, let's say here is 10 degrees Celsius, here is 20 cm cube. The area under the graph would be 10 degrees Celsius times 20 cm cube. So the unit will be 200 degrees Celsius cm cube. Okay, this is just if we are wondering what is the unit for the area under the graph. If I'm asking for what is the unit for the gradient, okay, area under the graph is degrees Celsius cm cube, but for gradient would be the y value is cm cube, okay, over the x distance, the y distance over the x distance. I'll get something like this, cm cube over degrees Celsius, which is cm cube per degree Celsius. Okay, sorry, this graph a bit small, but the point here is to try to read the values from the graph. Okay, Ken. Okay. Welcome, Connie. Sorry, before you guys go, right? Before you guys go, can I just do part ABC for the next example? Part ABC for the next example. Very quick one. Okay. State the relationship of x and y if the graph of y against x is drawn. So for part A, we are drawing y and x. Okay, we are drawing y and x. So I want you to just roughly draw out your graph, very simple one. There is no y-intercept. The y-intercept is 0, and the gradient is positive. Okay, so your graph looks like this for part A. I repeat, you have y equals to 2x plus 0. The gradient is a positive value. Look like this. And also, the y-intercept is 0. So this is your graph. So the relationship of y and x is y is directly proportional to x. Okay, y is directly proportional to x. Part B. Okay, find the relationship of y and x if the graph of y against x is drawn. Okay, let's try to just roughly draw the graph. I have a y-intercept, okay, and my gradient is a negative value. Positive gradient is like this, negative gradient is like that. So your graph looks like this, okay? If you ask me, this value is 5, because that is the y-intercept, and the graph goes down, negative gradient like that goes down. So this one we can say y is decreasing linearly. Linear means in a straight line with x. Okay, last one for today. We are drawing y against x one more time for part C. The gradient is a positive value, so the graph slants like that. And then the y-intercept is -3. Some people might draw like this, which is fine now if you want to state the relationship only. Or some people might draw like this actually. The important point is it won't pass through 0. It won't pass through 0. The y-intercept is -3. So if you draw like that or draw like that, it doesn't matter, but this is the better one. Okay, important thing here is it is not directly proportional, because directly proportional must pass through 0. This is what we call as y is increasing linearly. Okay, you see it goes up, increase, it goes up in a straight line. Linear means straight line with x. Okay, we'll stop here first today. We continue the rest in the next class. Okay, so if you are done, you can go. Welcome. Bye-bye. If you're done, you can go. You got any question, you can ask. Welcome, Ayman.